let's use expected value to determine what may happen in the long run when we play this game. So it does tell us here that we have these odds, 7 to 2 odds that we're given, that we cannot roll 2 even numbers with the roll of 2 fair dice. That means, in other words, that we'll get $7 if we succeed and $2 if we fail. And we're asked to first determine the expected value. So to do that, what we want to do is use the amount that we would earn, that would be $7, times the probability that we would get that success, in other words, that we roll 2 even numbers. And for right this second, I'm just going to put probability of 2 evens. We'll determine that in a second. And that's a gained amount. So notice that 7 is positive. But then there's also the chance that we could lose. So if we're going to lose, that must be a negative amount. So I'm subtracting here $2 if we lose. And that's going to be times the probability that we don't roll 2 evens. So again, I'm just going to put probability of, not 2 evens, just for a second. Okay, so now I want to determine what are these probabilities. What would I put here for those values? So this is where I'm going to use the table that the MyMathLab provides. And what I'm looking for are 2 even numbers. Well, if I look, I'm going to look through the rows. You don't have to look through the rows. You could look through the columns. But if, let's say I focus on this row, I know that 1 and 1, those are 2 odds. 1 and 2 is an odd and an even. But regardless, that whole row would contain at least 1 odd. So I don't even want to consider it. And if I use that same logic, I could mark out the row with the 3s and the row with the 5s. So now what I'm left with is looking at row 2. I want to see what are the specific outcomes where I'm rolling 2 evens. And that happens here, here, and here. Notice that was a 2 and a 2, a 2 and a 4, and a 2 and a 6. So I can continue that, identifying through my table other evens. And I end up with a total of 9 out of the 36 possibilities that I will roll 2 evens. So when I come back to that probability, remember earlier I just put probability there of 2 evens, I'm going to erase that and I'm going to put here 9 out of 36. And I could go back through and count up all the other possibilities to get the probability of not rolling 2 evens, or I can use that fact that 1 minus the probability of success would be the probability of failure. So in other words, 1 minus 9 over 36 tells me the probability that I do not roll 2 evens, and that's going to be 27 out of 36. And so multiplying, then subtracting, we should get 0.25. And that's why you see this value up here. So through the rest of this problem, it's asking about what does that really mean? So should you expect that happens on the first game? No. We don't expect that happens in any particular game. What this tells us is what's the expected value. If we were to play this game over and over many times, we would expect on average that this is the outcome, the 0.25. Notice it is positive, so that is a gain. And so if we played the game 100 times, we could just simply do 0.25 times 100 to get the $25 here. And again, because it's positive, that means it's a win for us, and we expect to win $25.